Hello, good evening, everyone. Okay, just to see that, I will take up directly to the concept now. We will ask this question for about 2 marks question. State Newton's law of gravitation. Basic question. Even from high school level, even 11th or 12th standard, we have studied about this. It is a basic idea. Without that, we cannot go for the Kepler's laws, that planetary motion, that derivation, everything that is okay. If you want to take up the derivation under the Kepler's laws of planetary motion, we had to learn what is this Newton's law of gravitation that states. The simple idea: consider a body whose mass is equal to capital M and another body whose mass is equal to small m, and the distance between these two body is equal to small r. Then according to Newton, from this body to this body, there is always a gravitational pull. I can say gravitational force of attraction. It becomes a repulsive force. Always it is said to be an attractive force. The gravitational force of attraction between any two celestial bodies, or I can say even on the Earth's surface or outside the Earth's surface, whatever it may be, one body mass is m, another body mass is m, small letter m here. The distance between these two is equal to small r. Then the force of attraction between these two bodies is given by F is equal to minus g into mass of this into mass of this divided by the distance square. The negative sign indicating here to here there is a force of attraction. And in terms of vector quantity, if you want to write, you have to introduce with a r cap also here. Okay, this is Newton's law of gravitation. This is the Newton's law of gravitation. We will ask this question for about 2 marks question. Under 2 marks question, we are framing this question. Now we are supposed to take up a very important concept, that is derive Kepler's laws of planetary motion from Newton's law of gravitation. I will consider Newton's law of gravitation. Using Newton's law of gravitation, we will derive Kepler's laws of planetary motion. All the three laws, of course. First law, second law, and third law. To consider that, first we had to think about Newton's law of gravitation. We have already aware of this. Now we will going to consider mass of the sun is equal to capital letter M, where capital M representing the mass of the sun. Round that sun, consider a planet whose mass is equal to small letter m, which is revolving round in its gravitation. Of course, don't forget, sun producing a gravitational field. In that gravitational field here, including the earth, it is a revolving around the sun. All the planets are revolving around the sun in its gravitational field. Since already we know that gravitational force of attraction, whatever it has been studied, it is said to be a central force here. It is a central force. And we have considered already, in the case of a central force field here, any particle or any body, if it is moving, whose aerial velocity remains constant. Since Earth or any planet which is revolving around the sun in its gravitational field, and we know that the gravitational field is said to be a central force here, and we know that already in the case of a central force field, the aerial velocity remains constant, and that is said to be the Kepler's second law. Only Kepler's second law, if we are asking, we will ask this question for about 2 marks. Derive Kepler's second law. Explain how you are going to prove the Kepler's second law is valid. 2 marks. Now we will take up the other ideas, that is. So what is that? First, let me consider the polar coordinate system idea. Aerial velocity, we know that half r square theta dot is a constant. Aerial velocity half r square theta dot is a constant. That constant I will take it as a h. One alphabet it has been chosen, not necessarily h. You can consider even s, t, x, y, alpha, beta, something you can consider as a constant h. Here I have chosen as h. Now r square theta dot, cross multiplication, r square theta dot is equal to 2 goes here, 2 into h. Okay. So this just I will going to multiply with 2 here. I will take that one as equation number 1. Let us substitute wherever r is there 1 divided by u. Wherever r is there, I suppose to substitute 1 divided by u. Therefore 1 by 2, 1 by 2, here it is r square 1 by u square into theta dot is equal to h. This 2 goes here. You are going to get 1 divided by u square. Theta dot is equal to 2h. Otherwise, you can substitute here only, no problem. 1 divided by u. R square 1 divided by u square. Theta dot. This 2h as it is. Okay. Now, we know that r is equal to 1 divided by u. If I am choosing r is equal to 1 divided by u, I will going to differentiate now. So do the differentiation with respect to time. R is equal to 1 by u, differentiate with respect to time. Therefore, dr by dt is equal to minus 1 by u square into du by dt. Basic differentiation. This one I will write in terms of du by d theta. This one du by dt can be written as du divided by d theta into d theta divided by dt. Function of a function. And this du by d theta as it is I will put it du by d theta. But d theta by dt I will write that one as theta dot. But we know already 1 divided by u is equal to r. 1 divided by u is equal to r. And 1 divided by u is equal to r here. Therefore, r square theta dot is equal to 2h. We know this also. R square theta dot is equal to 2h by taking by the previous idea. R square theta dot is equal to 2h. That is equation number 1. Now already we are aware of that. R square theta dot is equal to 2h. Equation number 1. I will select that equation here. R square theta dot is equal to 2h. Okay, r square theta dot that is equal to 2h here. Substitute wherever 1 by u square is there, I will put r square. Minus 1 by u square, I will write that one as r square. But we know that r square into theta dot is equal to 2h. R square theta dot is 2h. Minus sign as it is du divided by d theta. Now I will take the second order derivative. Means again differentiate with respect to time. R dot we are having. R double dot is equal to how much? R dot means dr by dt. R double dot means d square r divided by dt square. Differentiate again with respect to time. D by dt of r dot. That is equal to here d by d theta of r dot into d theta divided. This is actually it is a function of a function here. Here it is with respect to time. Here I will write first differentiate with respect to theta. The theta again we are differentiating with respect to time. So d by dt of d r dot is equal to d by d theta of r dot into d theta divided by dt. But we know that d theta divided by dt is equal to theta dot. This value is equal to theta dot. This one as it is, it has been written dr dot divided by d theta. Dr dot divided by d theta is written here. But this value is written as theta dot. Therefore, r double dot is equal to theta dot as it is, theta dot written here, d by d theta of r dot. R dot value already we know that minus 2h du by d theta. Substitute that r dot value here. This r dot value, this r dot is there now. This r dot value we are supposed to substitute. Multiply. Minus 2h theta dot d square u divided by d theta square. But we know that theta dot divided by u square is equal to 2h here. This is theta dot r square, correct? But r is equal to 1 by u square now. Therefore, theta dot divided by u square is equal to 2h. Theta dot by u square is equal to 2h using this. Therefore, theta dot is equal to cross multiplication 2h u square. So, substitute that value here now. Theta dot, for that theta dot, we are supposed to substitute this 2h u square minus 2h, this minus 2h, theta dot 2h u square here, d square u divided by d theta square as it is. Therefore, r double dot is equal to 2 2s are 4 h square u square d square u divided by d theta square. Now the gravitational force on the planet is given by, according to Newton's law of gravitation, where capital G is called by the name the universal gravitational constant. F is equal to minus G into M divided by capital M, mass of the sun, small m, mass of the earth or any planet, divided by r square, the distance between the sun to the planet. But we know that Newton's second law of motion, F is equal to ma, where a instead of that I have written ar, radial acceleration. So force is equal to mass into acceleration. Newton's second law. Radial acceleration of the planet is given, and radial acceleration of the planet we know that already, r double dot r theta dot square, r double dot r theta dot square. This is already we have derived under the radial components of velocity as well as the radial component of acceleration. It has been chosen from that particular derivation. Radial acceleration is equal to r double dot minus r theta dot square. Substitute that. This ar, I will substitute this. Okay. So F is equal to here. F is equal to this value, where ar is equal to this. Therefore, m into F is equal to here m into ar value is this. I have written this is equal to this value minus gmm divided by r square. Small m get cancelled on both the sides. Remaining thing r double dot minus r theta dot square is equal to minus gm divided by r square. Okay. Next stage. Here whatever we got, r double dot r theta dot square is equal to minus gm divided by r square. But don't forget about what is that value of r. Okay, so now let us do that concept here. But r is equal to 1 divided by u. 1 by r is equal to u. 1 by r square is equal to u square. And we know one more thing also, theta dot divided by u square is equal to 2h. Therefore, theta dot is equal to 2h into u square. So all these things already we are aware of this. So use all these concepts here. What is that? So again I can repeat that. Okay. See that r double dot here, r double dot r theta dot square is equal to this. 1 by, this is r square, 1 by r square is coming here. 1 by r square is equal to u square minus gm into u square you are going to get. Okay. So therefore you are going to get, here it is minus gm into u square. Substitute everything. Take from here, substitute in this equation. R double dot r theta dot square. Here r double dot, see that r double dot value is this. Okay, minus 4h square u square d square u divided by d theta square. Substitute this value. Substitute this value here. And we know r is equal to 1 by u theta dot square minus gm into u square. Clear? Where r is equal to how much again? You can substitute the r value here. And r dot value is this minus 2h du divided by d theta. Substitute all these things, whatever we have derived so far, substitute everything in that equation. You are going to have minus 4h square u square d square u divided by d theta square minus 1 by u, this square, theta dot square, minus gm divided by r square it was there, now it is equal to multiplied by u square. Okay. Now, 4h square u square d square u divided by d theta square with a negative sign minus, expand this, nothing else, 2 square h square u to the power 4 divided by u. Okay. One u get cancelled. Simplification you do it. Then the next idea, divided by minus 4h square u square throughout, means every term, this term divided by this and this term again divided by this term also it has been divided by this particular quantity 4h square u square. See that? Simplification is to be done. Whichever it is going to get cancelled, you cancel it. Simplification you are supposed to do it. So negative sign also get cancelled. Here you are going to get d square u divided by d theta square plus minus into here minus get cancelled. This is u is equal to, again negative sign get cancelled, gm divided by 4h square. Take this term to the other side of the equation, minus is equal to, here it is 0. Okay. Now let me consider this, whatever it has been rounded off here, I will take that one as another constant. Because u is a constant, already we know that. G, capital M, 4, h square is a constant. I will take this one as another constant here, that is u dash. A new constant. Okay. So I will take this one as u dash. Therefore, d square u divided by d theta square, this one I will replace that one by u dash is equal to 0. Clear? Now, going back here, we know that u minus gm divided by 4h square is equal to u dash. Differentiate this with respect to theta. Du divided by d theta, it is pure constant. Differentiation of a constant is equal to 0 is equal to du dash divided by d theta. Again differentiate with respect to theta. This one, second order derivative. D square u divided by d theta square is equal to d square u dash divided by d theta square. Now substitute this. Here d square u by d theta square is there. In place of d square u by d theta square, I will put this. D square u dash divided by d theta square. This u dash is equal to 0. Okay. This one, it is in the form of a standard equation. Okay. The solution for the standard equation is this. A cos theta plus b sin theta. I will put the initial condition, means boundary condition. Let me consider b is equal to 0 as a boundary condition, chosen as b is equal to 0. As if I am choosing b is equal to 0 here, then you are going to have u dash is equal to a cos theta plus this is 0. But u dash is equal to, you know that already, u dash is equal to u minus gm divided by 4h square. Substitute that. U dash is equal to u minus gm divided by 4h square. U dash in place of this is equal to a cos theta. But u is equal to 1 by r minus gm by h square a cos theta. Let us multiply throughout by 4h square divided by gm. Means every term, this term also multiplied by this term also multiplied by this. Therefore, you are going to have 4h square gm divided by this r minus 4h square divided by gm into this is equal to 4h square gm into a cos theta. Here it get cancelled. This gm coming in the denominator here. Okay. Yes. This is the concept that we are going to get it here. 4h square gm divided by r plus is equal to, of course, here it is equal to 1. Everything is get cancelled. There it is. If you are dividing, then you will get 1 here plus 4h square a cos theta divided by gm. This equation, it is in the form of L by R plus is equal to 1 plus E cos theta. This is the equation for a conic section. You are aware of what is a conic section? Section of a cone. Which are all the sections of the cone? Ellipse, circle, parabola, hyperbola, all these things. Now in this case here, E is said to be the eccentricity. Since eccentricity is less than 1 here now, it must be an ellipse. E is less than 1. This is E less than 1. Therefore, it is said to be an ellipse. And in the case of ellipse here, latus rectum, whatever the semi-latus rectum is 2L, semi-latus rectum is equal to L. So this is semi-latus rectum here, 4h square divided by gm. And E, eccentricity, is equal to 4h square a divided by gm is less than 1. Therefore, the conic section, whatever we have proved so far, since E is less than 1, it must be an ellipse. If it is an ellipse, it says that Kepler's first law is holds good. Means the planet, including the Earth, which is revolving around the Sun, is always moving in the form of an ellipse. It cannot be a circle. It cannot be a parabola. It cannot be a hyperbola. It must be an ellipse. Since E is less than 1. Okay. And latus rectum, already we are aware of that. Semi-latus rectum also we have calculated. This is Kepler's first law. Now, Kepler's third law. T square is directly proportional to AQ. So, what is that concept? So, we know that this is the focus of the ellipse. This is the planet, including the Earth may be present. This is the position vector. This is length of the semi-major axis, length of the semi-minor axis. This is semi-latus rectum. This is an ellipse. L is the semi-latus rectum. The semi-major axis of the ellipse is given by, according to your 11th or 12th standard mathematics, I can say, the semi-major axis of the ellipse is given by L divided by 1 minus E square. Formula, this is A is equal to L divided by 1 minus E square. This is the formula taken from your previous, whatever you have studied the courses. So according to your 11th or 12th standard mathematics, I have borrowed that one. From there it is semi-major axis of the ellipse is given by A is equal to L divided by 1 minus E square, where L is the semi-latus rectum, E is the eccentricity. The semi-minor axis of the ellipse is given by, this is semi-major axis, this is semi-minor axis. The semi-minor axis is given by B, that is equal to A into square root of 1 minus E square. A value, already you are aware of that. Substitute that A value multiplied by this 1 minus E square under the square root. Therefore, B is equal to L, as it is I have written, square root of 1 minus E square divided by 1 minus E square means if you are cancelling here it is, here you are going to get a square root. So, B is equal to L divided by root of 1 minus E square. Now, area of the ellipse, this is an ellipse now. If this is an ellipse, area of the ellipse, because I want to calculate how much is the area covered here by the planet. Time taken by the planet to make one rotation is equal to capital T. But how much is the area covered? Area covered is equal to area of the ellipse. The area of the ellipse is equal to pi times AB. Area of the ellipse is pi times AB. Pi into A value is the known thing. A value is the known thing, substitute. B value is the known thing, substitute here. A value, B value. Pi AB. L into L, L square. This is raised to the power 1. This is raised to the power half. Again I can repeat. 1 minus E square raised to the power 1. 1 minus E square raised to the power half. Bases are same. Indices law, that is, this is 1 and this is half. 1 plus half is equal to 3 by 2 power. A to the power m into A to the power n is equal to A to the power m plus n. Here 1 minus E square raised to the power 1 plus half, that is equal to 3 by 2. The period of the planet is equal to t. How we are going to calculate the period? How much is the area covered divided by the aerial velocity? That is a period. Area covered by the planet, that is area of the ellipse, divided by the aerial velocity, you are going to get the period. Area of the ellipse is S, and that S value is this. This is the area of ellipse divided by aerial velocity. We know that already, it is said to be taken as h. So substitute. This 1 minus E square raised to the power 3 by 2 goes to the denominator. Therefore, t is equal to this. T square is equal to square of this. Square of this. Square of this means pi becomes pi square. L square becomes L to the power 4. Here h becomes h square. 1 minus E square raised to the power 3 by 2 becomes 1 minus E square raised to the power 3. I will write this L to the power 4 as L cube into L. This L divided by 1 minus E square. L divided by 1 minus E square. I will show that L divided by 1 minus E square. Here L divided by 1 minus E square is A. Therefore, you are going to get this is as A cube. Whatever it is rounded off with red now, it is said to be taken as A cube. Here I will take L divided by remaining L divided by h square. L divided by h square. What is this L divided by h square? We have to think. Okay. So L divided by h square, we can replace that one by what? We know that L is equal to 4h square divided by gm. L, semi-lattice rectum, we know that it is equal to 4h square divided by gm. H square, you take it here. L by h square, that is, h square is here. You borrow that one to the denominator here. L by h square, 4 divided by gm. So in that expression here, L by h square, you remove that here. Pi square A cube L by h square. I will remove this and I will going to put 4 divided by gm. Okay. 4 pi square gm. This A cube as it is. Pi is a constant, 4 is a constant, g is a constant, universal gravitational constant is there. Capital M, mass of the sun is a constant. Therefore, the whole thing 4 pi square divided by gm is a new constant. Therefore, t square is equal to a constant into A cube. This constant, if I am removing, and if I am removing this equal sign also, we will get t square is proportional to A cube. T means time taken for one rotation of the planet around the sun. Square of the time period is directly proportional to cube of the semi-major axis. This is Kepler's third law. We will ask this question for about 5 marks. Okay, right? Okay, all the best.